In number 19, we're given this equation, and ultimately our goal is to isolate n, to get n equals blah, 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 using, let's say, algebra rules, and see which choice is matches, right? So these are all essentially equal to n, and so we need to rearrange this equation accordingly. So let me first do it by hand, and then I'll show you how to use Desmos. So let's write our equation. We have 12 over n minus 2 over t is equal to negative 2 over w. And the pain here is we have this annoying n in the denominator. So kind of a few approaches here. What I would say is probably the best way to do it. There could be other ways. But the way that it immediately jumps to mind here is let's just move this over here. Let's get the term with the n by itself, and then we'll deal with what's left. So 12 over n would equal 2 over t minus 2 over w. When I add 2 over t to both sides, I get this. Let's now combine these fractions, because part of the challenge here is these are all in the denominator, and it's kind of annoying when they're in the denominator like this. So my goal is to get them out of the denominator, but first I want to combine these into one fraction, because that'll create some flexibility with how I can handle this. So I need to get a common denominator, so I'm going to multiply this one by w over w and t over t, because when I see the denominators are originally t and w, a good common denominator would just be the product of those wt. So I'll multiply this by w over w and this by t over t so that we get that common denominator. So I'm going to get 2w over wt minus 2t over wt. And now that they have the same denominator, I can just subtract the numerators, right? 2w minus 2t all over that common denominator of wt. And so what's good about this is I am now able to take a reciprocal of both sides. You may have been tempted initially to take a reciprocal of both sides. It would not work. Like you can't do n over 12 minus t over 2 equals negative w over 2. You can't do that. That's not allowed. What you would technically get, yes, you'd get negative w over 2 on the right, but on the left, you would just get 1 over 12 over n minus 2 over t. This is not helpful at all. I can't deal with this very easily. So instead, if we can get it as a fraction equaling a fraction, then I can take the reciprocal of both sides. No worries. So now I can do that flip. And now I'm very close to done. All I got to do is just multiply both sides by 12 to get rid of the 12 here. And I have my n equals. So it's going to be wt over 2w minus 2t times 12. And just note that this denominator is the same thing as 2 times w minus t. And so this factor of 2 will cancel a factor of 2 in the 12, leaving us 6. So I'm going to get 6wt over w minus t when that all simplifies. And that is going to match which one? It's going to match choice D. With Desmos, there's a few options here. One option is to keep n a variable and plug in a number for t and for w, and then make sure we plug in the same values below and just see what matches. So for example, so let's do 12 over x. We're going to turn n into x so that we can graph it, minus 2 over, let's just pick some numbers here. So maybe do t is 5 and w is 6. How about? That seems fine. As long as n, t, and w are positive, we should be good. We just got to make sure our x is positive. I guess it's fine. It should be fine. We're just going to be looking at when x were to the right of the y-axis. If n is positive and we're calling n x, then we're just going to look at this region of the graph. I don't think it'll matter, but just in case. So 2 minus 5 equals negative 2 over 6. Okay. So I zoom out, and notice we're going to get, since this is really just something we can solve for x, we're going to get a value for n, which turns out to be 180. Okay, cool. And that's good because that's greater than 0. So now what I'm going to do is I'm going to just plug these choices in and see which one gets me the same thing. Like this is not really a graph of a function. It's really just the graph of x equals blah, blah, blah. Whatever the value of x is that satisfies this is right here. So it's 180 apparently. I just need to see which gets me the same thing. So 12tw, so 12 times 5, whoops, times w is 6. So I get 360, which is not really going to work. And actually, I probably should do, these are all equal to n, right? So technically, this is x equals this. So that line doesn't match. How about x equals 6 times t minus w? So 5 minus 6, that's not going to work. How about C, x equals w minus t. So 6 minus 5 over 6 times, I don't think this is going to work, 6 times 5 times 6. Nope. So hopefully choice D works, right? 6 times T and W. 6 times 5 over 6 minus 5. And this has got to equal X. Okay, so yeah, we get 180. Cool. So we can see if I turn these off for a minute because these don't work. If I toggle the black curve here, it is the same thing as the red. So it matches choice D, and that's our answer. Now, if dealing with these vertical lines is a little weird, if you'd rather actually have a curve that you can match, we can do that. All we need to do is just keep 2 of these unknowns a variable and just plug in a value for one of them. So let's turn, let's do n as y. So 12 divided by y minus, and let's do t as x, minus 2 divided by x equals minus 2 divided by, and let's make w6. We'll just keep it that. Okay, so now I get this curve. For my choices, I'm going to plug in the same things. I'm going to say, for choice A, these are all equal to y, right? They're all equal to n. So I could write y equals. I don't really have to. I'll just ignore it, and I'll just write the rest. So it's going to be 12 times t, which is x, times w, which is 6. And this is very not close. This is some line. This is this green line right here with a very steep slope. That just is not correct. Also seems like B is going to fail because it's going to be a line. So 6 times, so t minus w, so x minus, we said w is 6, right? So that's not going to work. It's this purple line. So how about C? So w is 6 minus x divided by 6 times x times w is 6. Okay, well, we get something that's not linear, but it doesn't quite match. Let me turn these off for a minute. I'll turn this off. No, we want the blue one. So here's the blue one. The blue one is this, and then what we just graphed is this black one, which is like this. They don't line up. So again, hopefully it is D. So 6, we did t as x times w, which is 6. Divide all that by w, which is 6 minus x. Aha. So it clicks into place. If I zoom out and I toggle this red curve, we see it perfectly overlaps the blue. Perfect. So again, we know the answer is choice D.